Hello everyone, welcome to my channel. So as we discussed in the previous short, we are starting the new subject in our channel, that is Introduction to Nanotechnology. So this particular subject is there for many universities, okay, and under VTU we are having this subject is again one more common subject for first year students, where from 32 scheme onwards. So usually this particular subject, okay, will come under this particular what you say our ETC, that is integrated this thing. So here we have this is the code for BETCK105C or bar 205, because some semesters it will be in first semester and some semester it will be because of the physics and chemistry cycles. Okay, so the subject is also same thing, which shares for 50 marks per CIE, that is continuous evaluation, internal evaluation, where you get it for assignment, all these things and all, even assignment, quiz, or even your internals. And CE, that is for external exams, SEM external exams, that is 50 marks, here it is mentioned, and total marks is 100, and teaching hours, all these things it doesn't require for our classes. What you should remember is the marks and total credits. It has got 3 credits, that is very important, and so these are the teaching department, all these things. So since this nanotechnology is not completely a new technology, so it's just about the scale, what you study for physics and chemistry and any other engineering materials aspects. But since any material size goes less than 200 or 100 nanometer, the properties changes. So those properties again come into optical properties, the electronic properties, which comes under all physics, and maybe more aspects about electronic properties, and the material science properties, hardness or magnetism, all those things comes under the material science and other engineering branches. Whereas the chemistry, because since the materials is reduced to the nanoscale, surface is exposed to more compared to the volume, surface is more. That's when you get the chemical properties, all those things. So this subject can be taught by the nanotechnology graduates or postgraduates, or chemistry, physics, engineering branches. So I myself has got a master degree in nanotechnology. So I chose this subject because I had worked under the nanotechnology department for 8 years. So this subject is a very good subject to to impart or to bring out what exactly is happening in the right now world and outside India. Maybe if I has to be specific, because a lot of technologies do come, but we will not take advantage of it. Most of the developed countries already taking advantage of nanotechnology. So the best thing what VTU did, that they have introduced this subject and made it compulsory for all the engineering students to learn, so that in future if they are interested in this particular subject, they can go through this particular subject, and they can do projects, even though you are a mechanical engineering student, you are a biotechnology engineering student, or even any kind of branch you belong to. The nanotechnology can be applied into that particular branch. How? Because every field you go, you deal with certain materials, and when you speak about materials, there comes all these properties, all these things. And what is nanotechnology doing? As you are reducing the size to the nanoscale, maybe less than 200 nanometer, the properties are completely, they are changing from bulk to the nanoscale. So this is why we need the nanotechnology subject, because the more we are going towards achieving many goals each day by day. So we need to come up with new solutions to the existing problems. So existing problems are we are having existing problems. So we cannot apply existing solution to the existing problems, because we need to come up with the new solutions. So for that we are having the new technologies. The nanotechnology is one such field where anything material related, any properties, that this and all, any property related, structure related, okay, any kind of issues are there, or better understanding and all these things, then we can reduce the same bulk to the nanoscale. And when you reduce bulk to the nanoscale, every property changes. It has been observed that gold at a bulk level, we know that it's a yellowish in color, but when it is reduced to the nanoscale, 100 nanometer or 80 nanometer, it changes its color to the purple, purple and different variety colors, violet color and red color, all these things. That means as the size falls less than the 200 or 300 nanometer, the properties are getting changed drastically. Here in our example, the optical property of the gold particles exhibited very differently. They are behaving completely differently when it is in bulk. So that's make them important candidates to study different optical parameters, or the possibilities, so that we can understand the particular the beauty of nanotechnology. One such example is if you trace back to the 4th or 5th, 7th century, the kings used to use Lycurgus cup. So Lycurgus cup was one of the very famous cup, okay, in the Roman period. So where this particular Lycurgus cup used to appear green in color whenever the light is reflected. That means when this is a particular glass, when the light is reflected from outside, so it is showing you the whole glass will appear you green in color. But when the light is transmitted through the cup, that means if the light is transmitted through the cup, what happens? The glass used to appear red in color. So when the scientists were this is preserved still in many in UK, this thing and all, so museum and all, and when they checked the properties of this particular Lycurgus cup, what exactly the property, how come this particular cup is changing its color. So when they observed the walls of this particular cup, and when they took off the samples, and when they viewed under electron microscopes, but as earlier also scientists attempted to understand by the help of optical microscopes, but they were not able to identify anything. But when they were able to find, when the electronic microscope was introduced by the IBM, transmission electron microscopes, and scanning tunneling microscopes, scanning electron microscopes, and then these particular samples were taken and viewed under the electron microscope, and when they viewed, and they came to know that the existence of silver and gold nanoparticles along with the stannic oxide nanoparticles present on the walls of the Lycurgus cup. That means what? The particular materials, when they are reduced to the nano scale, they are giving very different color. As I told you the example of your the gold, the same thing is happening here also. So now the question arises, then whether this technology is new, because we just spoke about 400 BC and 7th century and other things, right? So here is the answer. The technology or the methods, it is not at all new. Okay, so methods, whatever they were doing since very long year, what they used to take a gold and heat it to up to the 1000 degrees Celsius. Then they used to get this particular fluid, the gold liquid sample, and with the help of this, suddenly they used to purge all these materials. They made swords. This Damascus sword was one of the famous swords. In 4th century, it has been used in Damascus. So now what you call as Syria, right? So all these, that was well known for its hardness and strength because of and later when the same thing approach was taken and into consideration, when they viewed under microscope, they came to know that presence of carbon nanotubes and silver and gold nanoparticles present inside this particular sword. So what exactly is all these things is trying to say us? They knew the methods, our ancestors knew the methods, but as of now we don't know the method, how exactly what method they used to purge those swords and this for making these cups and all. But we do know what exactly why exactly they were magical in terms of their properties. For example, the Damascus sword was well known for its hardness and strength. It has been said that if you use this sword to cut the silver threads, silk threads, it will be, you just strike it, all the silk threads will be cut. You know how hard the silk threads will be. And also, if you can by simply hitting on the stone, you can break the stone, but nothing happens to this particular sword. That means how much, that shows its sharpness and hardness. And speaking about Lycurgus cup, we just told you, in the same room with the reflected color, for a person who is there where the light is reflected on this particular glass, he is seeing the glass as a green, and when the light is transferred through this thing, so the glass is turning into the red in color. So again, that beauty came because of the nanoparticles, right? So that we were able to explain it now scientifically. So that's the difference. So they knew the methods, now we know the technology. So that's why the nanotechnology nanotechnology is playing a very important role, not only this material aspects in biomedical field where targeted drug delivery can be used, where the particles can be used along with the antibodies by loading the drug, and it can be transported into the particular devices where into our human body, so that the particles will go there and sit there, and they will deliver the anti-cancer drugs only to the anti-cancer cells because of the antigen antibody specificity. Okay, if you are talking about the aerospace, there are applications in aerospace, automobile there are applications, environmental engineering there are applications, marine engineering there are applications. If you speak about CS, okay, computer science and AML, all those things, you speak about the quantum computation, you speak about supercomputers, all these supercomputers we are getting the supercomputers because of the size. As the size is reducing, what is happening? The applications are becoming more. We all of you know that Moore's law. Even in electronic field science, background people, they might ask me what is the application of nanotechnology in the material in electronics, E&C, or in CS, or any CS related field like AML and all. So everybody for E&C we have the circuit, transistors, right? So we are having the FETs, right? Nowadays we are having by using nanotechnology we can bring the quantum FETs, we can bring the carbon nanotube FETs, we can bring the graphene FETs. Okay, so instead of using the silver oxide, whatever the material we are having in between the source and drain, okay, and the base, so whatever the material, the channel material you are using, that material can be replaced by the nanomaterials, so that the electron transfer from the source to drain will be faster, so that the conduction will be faster. All these things can be the applications of the in the electronics field. When it comes to the electronics and CS field, we know that Moore's law, every 18 months the number of the transistors sitting in a particular area of a chip is doubled. In order to double, what you need to do? You need to keep reducing the size. So that was stagnant before nanotechnology. Now, since the nanotechnology is there, that's why we are going further and further and further. Right, nowadays what is the size of a band gap in between one chip to another chip? The gap is around it's coming around 2 to 5 nanometer. Okay, one of my friend is working in Intel, who is working in all these particular circuits and all the chips and all. So he says, one other day we happened to talk about the nanotechnology, and he was sharing that they are already into the nano. So all these things, what it shows, the nanotechnology has got a great application in every field, whatever branch you belong, nanotechnology is there. Civil engineering is also for construction. They are reducing the particle size to nano size, and that's how they are getting the more hardness. And suddenly by using nanostructures, nanoparticles, they are making bricks. That brick will be will have more good mechanical properties than the normal brick which is being produced from the macroparticles or microparticles. So nanotechnology plays a very important role. It has got a variety of application in many fields. So the nanotechnology subject, whatever is there, which is introduced in you are lucky that this subject is being introduced, you can make use of it. Okay, so this is the syllabus we were discussing, and course objectives. The first thing is to provide a comprehensive overview of the synthesis and characterization of nanoparticles, how exactly we are going to synthesize the nanoparticles, and how we can characterize the nanoparticles, and why we have to characterize the nanoparticles, and nanocomposites and hierarchical materials with nanoscale features, all those things like properties, all those things we are going to discuss. And then to provide the engineering students with necessary background for understanding various nanomaterials characterization techniques, like we are having the XRD, all of you know, and the same thing can be used for the structural analysis for nanomaterials also. Then we are having the SEM, that is scanning electron microscope, where we can use the electron microscope to scan on the surface of the materials, or the samples, so that we can understand what are the sizes of the nanoparticles. And then also we are having the transmission electron microscope, which will give us the three-dimensional structure of the nanoparticles, not only the size but also it will tell us the shape of the nanoparticles. Next, to develop, these are all the characterization techniques, those we can use, so you can study. We are having the scanning tunneling microscope also, and AFM also, which has been developed by the IBM, and they got Nobel Prize for developing the STM, scanning tunneling microscope. Why? Because the beauty among the difference between all the electron microscope and STM is that by using STM we can pick a single atom and we can place in other sides. By using this particular mechanism or the property of this STM, the IBM was able to pick every individual atom, and they were able to make the IBM logo with the help of STM through the atoms. So that's very amazing concept. It's not a joke to play with atoms, right? So but with the help of nanotechnology and the tools and techniques what we are having, electron microscopes, it is possible to develop understanding the basis of the choice of the materials for a device applications. That is your third CO. Okay, like what kind of devices can be made out of the nanotechnological applications and for what applications that we can study, and to give insight into complete systems where nanotechnology can be used to improve our everyday life. These all things can be studied in this particular subject. That's why the 4 COs are there. Next, teaching learning process. We know that we don't need that because it's about a video lecturing here. So check and talk, I use PowerPoint presentation with video this thing, and e-sources I'm giving for notes, gears, everything. Self-learning that you have to do. Okay, so the module 1, it keeps explaining about what is nanotechnology, introduction of nanotechnology, definition of nanoscience, definition of nanotechnology, different famous definitions, all those things. Then frontier of future and overview. That means how exactly nanotechnology is going to affect the future, and how exactly it is going to change the future and the world we live. All those things can be studied in this. Next, we are having the length scales. So length scales are nothing but the bulk to the nanostructure, how exactly the difference are there. Similarly, under this thing, various of physical properties from bulk to thin films to the nanomaterials, how exactly the property varies from the bulk material to the thin films and to the nanomaterials. Then confinement, it's the density of states you might have studied in physics, the same thing. Confinement in electrons, like for example 0 dimension means electron is confined in all the 3 directions, electron is not free to move, so it is 0 dimensional material. Then if the electron is free to move for 1 dimension, we call it as a 1 dimensional nanomaterial. If the electron is free to move 2 direction, like XYZ, you know, right? So 2 dimension, then we call it as a 2 dimensional material. If all the 3 dimensions are free to move, then we call it as 3 dimensional materials. So next we are having surface to volume ratio. That is one of the beautiful property of the nanomaterial, where when you keep on reducing the size of any material, its surface is getting more and exposed more and more, and its volume is getting shorter and shorter. So that's the ratio, surface to volume ratio is very high in nanomaterials. And why we need surface? Because every activity happens in surface, right? Every interaction happens on surface. So surface is very important, surface to volume ratio. Next we are having the synthesis of nanomaterials. Synthesis of nanomaterials, how exactly we are going to synthesize the materials. So there are majorly there are 2 types, 2 approaches, bottom up approach and top down approach. So in bottom up approach, we are having the chemical routes for synthesis, like for example salt gel method is there, precipitation method is there, under that co-precipitation, arrested precipitation will come. Then solution combustion synthesis method is there, hydrothermal method is there, that we are going to study, and CILR is there. in chemical bath deposition is also a part of bottom-up approach. Bottom-up approach in the sense from the particles to the clusters to the particles, nanoparticles you will get. That means from the atoms to the particles, to the clusters, to the molecules to the clusters. That means you are forming the nanomaterials from the atoms, from the other side, from small to nano, from atom to nano. Whereas in top-down approach, from the bulk, the macro particles to the micro particles, again you are going to reduce it to the nanoscale, right? So top-down approach, that means obviously milling technique is one such use where bulk particles can be made powdered form so that the nanoparticles can be reduced, and sputtering technique so that high beam of the force can be put onto the surface so that the sputtered atoms will go and deposit and they will form nanoparticles, layers or something like that. Next, laser ablation, also high beam of laser beam can be given to the structure where those particles, whatever the particles are there, if it is silver, then the silver nanoparticles can be synthesized like that. So that was about introduction under introduction module 1. In module 2 we will be discussing about characterization of the nanomaterials, like as I told you, the electron microscope, basic principles and instrumentation of the electron microscope. Like TEM we are having transmission electron microscope, SEM we are having scanning electron microscope, scanning probes, scanning tunneling microscope, atomic force microscope, different imaging modes, comparison with the SEM, TEM, AFM, STM, AFM, all these things. So usually the SEM is scanning electron microscope, it takes two-dimensional images of the nanoparticles. Okay, and also it gives the three-dimensional image of the surface, not whole particle, only surface. Then TEM is the one which will give you both two-dimensional and three-dimensional image of the whole particles, every particles. For example, if I synthesize nanoparticles, now it's not necessary that all the particles will be in spherical shape. Some of the particles will be in pentagon or hexagon or any other kind of rhomboidal kind of structures. And why do I have to know what kind of structure it is? Why do I have to know what is the three dimension? Because the surface plays a very important role. Without checking this characterization after synthesis directly, I cannot use it for applications. Why? Because the surface might change. To understand how much surface is there, whether it is spherical, whether it is hexagonal, whether it is pentagonal, whether it is square, all those things need to be understood first, so that we will come to know that how much amount of energy, the surface area is being exposed. Based on that, the applications will vary. Every time I cannot synthesize something and I cannot use it for some applications. That optimization is very hard at nanoscale. So we need to go for the understanding their characteristics, properties with the help of the electron microscopes. SEM will give you the morphology, TEM also will give you the morphology with a three-dimensional structure, whereas AFM will give you the soft, whether this particular AFM is nothing but atomic force microscope. So this will give you whether this particular surface is smooth or hard. All those things can be understood from using AFM. And then SEM, again the difference between the SEM and TEM, all those things. Next, basic principles, that was about all electron microscope. Then basic principles of X-ray diffractions. X-ray diffraction we have already studied in PUC, but in engineering also in physics again we will be studying this subject. Again same topic here, derivation of Debye-Skorrer equation. Okay, so that is the equation we directly use to calculate the particle size. Next, numericals on Debye-Skorrer equations. That means some of the numericals will be there based on this equation. That means some parts will be given, some of the lambda will be given, the value of some parameter will be given, other parameter you need to detect. Next, optical microscope. So instrumentation and applications of IR, UV visible spectroscopy, all those things that we will be studying based on for the band gap measurement. That was about the module 2, characterization of nanomaterials. Next we are having the module 3, which is nothing but carbon based materials. Carbon based materials, we are having the introduction, introduction to the carbon based materials. For example, what are the carbon nanomaterials, how exactly they look in the structure wise, property wise, all those things we will see. And the synthesis, how we can synthesize these particular carbon based materials, and the properties may be electrical, electronic or mechanical, and any other kind of properties. And then applications of the graphene, and single wall carbon nanotubes, multi-wall carbon nanotubes, that I will in detail explain you while taking the subject. Then fullerenes we are having next, the other carbon materials like carbon nanocomposites, nanofibers, nanodiscs, nanodiamonds, all those things we will be discussing. Then in the module 4 we are having solar cells, batteries, fuel cells. Under solar cells, first generation to the third generation solar cells we will be studying. Along with that, dye-sensitized solar cells, quantum dot sensitized solar cells we will be discussing. Then the batteries, we are having the lithium-ion batteries, their working, their requirement for anodic and cathodic materials where nanoparticles can be used there, and the advances in cathodic materials, anodic materials, separators where the nanomaterials are used, that will be discussed. Then fuel cells, introduction, construction, how exactly they work, and nanotechnology, how it is going to affect the hydrogen storage and proton exchange application membranes, that also we are going to discuss. Next, self study for long term, these things there, the supercapacitors that you can study, and you can also do some projects on supercapacitors. And next we are having the module 5 where application of nanotechnology, like nanotechnology applications and recent breakthrough, introduction, significant impact of nanotechnology, nanomaterials, medicine and health applications, biological application, biochemical applications like nanobiotechnology what we call. Next, nanoelectronics, where electronic application of nanomaterials, whereas nanocomputers, these are separate fields only. Here we have to just explain one topic. So computing applications, I cannot explain computing application, I cannot explain nanoelectronics in one particular topic. It cannot be explained in one particular module also. It's separate subjects are there for them. Okay. So, but for your understanding at the basic, we should just give a brief introduction about electronic applications or nanoelectronics, okay, nanocomputers or chemical applications of nanotechnology, that is nanochemistry, like nanophotonics, which are optical applications of the nanoparticles, agriculture and food applications, and recent major breakthrough in nanotechnologies. And also the self-study learning, we are having the photocatalysts and Lotus effect, that is super hydrophobic. Then course outcomes, there are 5 course outcomes: demonstrate the synthesis of the nanoparticles by various techniques, explain the working of the basic instruments used in the calculation of the nanoparticles, discuss the application of nanotechnology in chemical and mechanical and civil domains, classify the nanomaterials based on the domain by dimensions, assess the suitability of the nanomaterials for various device applications. So these are all nothing but this thing. Your SSC and CIE, you already know that the same thing was, and 3 tests will be there, 20 marks each, assignments for 40 marks, and quiz will be taken so that we can go for it. And then totally CIE marks for 50 marks, semester ends 50 marks that we discussed. And these are the suggested textbooks here. We are having the nanomaterials and nanocrystals, nanoessentials. Okay, nanoessentials, T. Pradeep is one of my favorite book. Okay, and we are having the other parts also. We can just go through Vilay books. Okay, solar cells and all. And these are some of the links they have given here. And then practical based learning. Okay, so that's how you are going to study based on the practical. The preparation of the silver nanoparticles and calculation of the particle size by optical microscope, preparation of zinc oxide nanoparticles, aluminum oxide, silica, metal, thermal conductivity of the nanofluids, preparation of thin films by Siller method. Okay, all these things you can go for it. And then these are the COs and POS mapping. That's it in the today's video. We discussed about the syllabus and give a brief introduction about how the nanotechnology syllabus is being designed and how exactly nanotechnology is going to nanotechnology syllabus we are going to discuss. How nano subject we are going to carry forward. So the few introductions I have given here, where I guess it will be helpful for understanding you the whole subject in brief. So from next video onwards, I will start the first module, that is introduction to nanomaterials, where we will start the what is nanotechnology, definition of nanotechnology, the history, the importance, the scope, the frontier of the future, that itself is a scope. Next, length of scales and bulk to thin films to the nanomaterials. Next, confinement for 0, 1D, 2D, 3D. Next, we have surface to volume ratio is there, bottom up and top down approaches, that we will discuss in the next class.